previously we made the main drive hubs and then we finished off the brake hubs with the keyway, and then we got everything ready to assemble. And then in this episode we'll start mounting some of those components onto the main drive plate.
Whoa, hold on there.
What's going on? I was in the middle of doing the previously and the coming up.
Well, there's three things. Let me bring you in a little bit closer and we'll explain. Okay, so the first thing is on this drive pulley here, at the last minute I decided to add this flange on here rather than making it a bolt-on extra part. I'd incorporate it into the pulley itself, and I did that, but I didn't do a back check into the CAD with everything switched on to make sure it was all going to kind of line up. And as you can see, the belt runs along here. This motor is just temporarily fixed here, but it's in the right place. You can see it runs up against that guide there, that edge, and on this side, so if I hold it straight, on this side where the belt wants to sit, it wants to ride on here. So by adding that, I pushed the teeth feature over, and I thought in my mind I had enough travel for the belt to fit. Clearly it doesn't. It wants to sit like that, which is at an angle. So I need to sort that one out. And no, I can't move the motor over because it's in slots. Yeah, I could elongate those maybe. I don't really want to do that, and anyway, there's another bigger problem.
So the belt arrived in the post recently, so I tried it out on the pulley, and unfortunately it doesn't fit. I've made an error somewhere.
Yeah, so I was slightly annoyed at that, but all my own fault. I made a very tiny error in CAD, and the thing is with timing belts like this, a very, very tiny error, a fraction of a millimetre error in the CAD, soon adds up, and before you know it, you lose synchronization. So effectively I've made not a 5mm pitch pulley, but a 4.93 or something, I think it was. You probably won't be surprised to learn you can't buy a 4.93mm pitch belt, and even if I could, the pulley that's supplied on the motor is only 5mm, so I need to fix that one too. Okay, and the third thing is these bearing blocks. The bearings have not been fully pressed home in their housings, which basically means the housing sits at a bit of an angle in various planes in relation to the bearing itself, which means these don't clamp down properly and they're a bit of an angle. I'm hoping the bearings are just simply pressed into these housings. I think they are, rather than cast in place. So I should be able to put these over on the arbor press and straighten those up, and then we'll get those back in line again. Cue the music.
Okay, so while he sorts that little mess out, we'll take you through some of the other activities that have been going on in the shop while you've been away. So here we are marking out the brake hubs and then aligning them. You see we've got them in the vise, using the keyway just to give us an alignment, get that square, and we're just picking up on those marks we made. Then we've got a 2 flute 6mm carbide end mill there, just using that to drill it out roughly to size, and then taking it out to 6.8, which is the tapping size. Just cleaning it, deburring, and here's our M8 tap. Now we've just used the traditional method of using a square to get that square in the 2 planes, and then gently hand tap that in. And then a final check with the 8mm grub screw just to make sure it was all going to fit.
Okay, so here's the brake dismounting flange. I've tapped the hole now to M8, done that on both of them. We've got all the keyways in, so that's the key for the differential, then we got the key for the brake disc, that's going to go on there, and then the key for the drive flange at the other end that goes into here. So I think we've got all the bits just to do a dry assembly, so let's just tap it all together and see what it looks like. So we'll start with this one. Okay, we'll measure the correct distance in a moment and just get that offset correct. Just tap it into the final position, but for now that one's okay. And then we'll put the let's put the bearing on at this end. And then the drive flange, which is this one. Okay, we'll just pop that in the vise to drive that one home. And then we'll just put this little M10 nylock on, just to hold that wheel hub in place. Okay, here's the first one on. Probably could have got away with this being a bit narrower. Looks pretty heavy duty on there. It's not going anywhere, is it? Okay, well that's one done. Let's do the other one. It just about fits over those keys, so that's good. Just hold that in place. Click. Okay, we've got our M10 lock nut now holding the hub on nicely. What am I doing? Turning into AVE. We've got our M10 nylock nut holding the hub on. Looks pretty good. I don't think that's going anywhere. Now if I put them down next to each other, you can see they're basically the same, except a slightly different length here because of the diff offset. Okay, so those went together okay. That was a bit of a dry assembly. I didn't want to do it with these in the way in case I bent them or they're just a little bit larger, get in the way. So I'll knock it apart, put these on, probably come in from this end, and then set those to the right distance, and then we can carry on the build down the axle. Okay, so I've knocked the hub back off again. Now I know it's all going to go together okay, and we'll get the brake disc on. These are held on with little torque screws, and they've got some thread locking compound already in, which is good. And the last one. Click. Yeah, it starts to look a bit more purposeful now. Okay, let's put the other bits back on again.
Right, time to start making the corrections.
Okay, so to press this bearing into its housing in here, because it was sitting at a bit of an angle, I made up these two press tools. So we just got this one. It's a simple ring, but then it's got this recess in here. I'll show you why that is in a moment. And then the other side is just a plain ring, and actually the bearing itself is slightly wider than the casting, so it's got to stick out one side or the other. So I decided to make it flush with this side here, which has got these small pockets in, and then that's the flat ring there, so that presses against the bearing until it can't go anymore and it hits the housing. And then on the other side we've got the one with the little pocket in it, and that just sits against the housing, so that allows the bearing to come through, and it will just keep going until it bottoms out on this side. Not easy to see on camera, but that is now pretty much even all the way around. Certainly a lot better than it was. Okay, so the cart's upside down now, so it's resting on these foam pads here. Looks like I need to just trim those back down, but that's fine. Okay, let's try that out. See if it's any better. So it looks a bit straighter.
So now the bearings have been straightened in the housings. They line up quite nicely with the holes. They're also now quite square to the shafts. That looks a lot better. Okay, looks good. So the shafts should run pretty true now. Now I need to move on to the pulley, get that fixed. So we're starting off here with a facing operation because I need to take it down about 2mm to get it down to 18mm. That's the final part thickness. This is a 20mm piece of stock. All the blue you can see there is Sharpie, so I marked it up just to make sure it's going to fit, because this is a bit out of my scrap box. And here we're going on to the pocket through the centre, so this goes all the way out to the other side. And then once through, there's a 2D contour just to clean up the inside of that bore. Next up is the counterbore pocket, so this is where the cap head screws will go. So this is the counterbore for the head. Just cleaning it up to get rid of some of the chips. This stock was out of my scrap bin, and I'd managed to break an end mill off in the part there, and then all the other holes were me trying to get that end mill out. Eventually I did manage to get it out, and then we could use it for this part. And now onto the two holes for the screws to pass through. And now we start the roughing operation for the teeth. So I'm using a 6mm 2-flute carbide just to rough out most of the material, and then a little bit later on the plan was to go in with a 3mm end mill to finish that off. Now, I didn't manage to catch what happened next on camera, but essentially I had a bit of an issue with chip weld.
What just happened is I got chip weld partway down here because it's getting quite deep now, and it stalled the spindle out, but the motor's kept moving, and essentially what it's done, as you can see down here, it's pushed the part out of position. So basically I've lost all my references. So I can pick up on the center, but that won't give me alignment. So what I'm going to do is just make a little tool on the lathe, just a quick tool just to pick up on these bores here. They're 15mm in diameter. So if I can drop something in there, I know it's 24mm from the center to there and to there. If I can get the spindle to drop into those two positions, then they'll be pretty accurate. I've only roughed out these teeth, so I've still got quite a little bit of material to take off. So if I get it within probably 0.1mm, maybe 0.05, it will be fine, and then I'll still be able to take off the rest and have a good part. Okay, so I've got the part back down on this kind of mini pallet here. I drilled and tapped a hole all the way through into this base so I can put this cap head screw through here. It's just sort of loosely in place at the moment. I'll get it roughly aligned. And what we'll do is just go across to the hole on the other side and carefully go down, and this diameter here is pretty close to that one there, so that should give us an alignment there. I'm just manually jogging this down. Should start to hit on that chamfer now. Hopefully push the part into alignment. Let's try that. Okay, it feels pretty good. And then we'll just put a couple of clamps on just to hold that down, and then jog onto the other side. Okay, so I've clamped it in loosely in position. I've got this at now Y minus 24. I've gone down, it looks like I'm pretty much in line, so we'll just gently lower that down. Right, let's get it all really rigidly clamped down and we'll carry on. I find these pad saws are quite a nice way to cut the tabs out. Okay, and there we are. Second go. So we've still got to drill and tap these little, I think they're M3 holes. They'll hold on another guide, belt guide on this side, which will be a separate piece, and that's where it bolts onto the diff housing. Right, so now we've just got to counterbore this side here on the lathe and tidy up these edges. Okay, so the pulley's now in the 4-jaw chuck. You can see I've just got it on these 3mm round brass rods, which fit nicely into each tooth. And then also you can see on there I've got it pretty much centralized on that bore. What we've got to do next is there's a counter bore on this side, as you can see in the section view, 4mm deep, and it's 60 wide, so it's that one. We need to take that out. So we're taking that out. What that'll allow is this pulley to move across on the main differential housing, which is this one. So it'll bolt onto here. But now, instead of registering on this feature, it will register on this outside feature here, and then we'll machine that off. We don't need that. Essentially what I needed to do was to move the pulley across so we have good belt alignment. Right, let's get on and do the counterbore. Quick test fit. Okay, while we're here we'll just clean up this edge, put a few chamfers on, clean up this edge here as well, and then when we're done we'll see you over at the workbench.
Just before we go over there, I need to machine off this flange off the end of the drive housing. You can see I've got a dead centre in there pressed up against the bearing of the diff. Then it's in the forejaw at the other end. It's been centralised, and so let's go.
Okay, let's give you a quick recap of where we got to. So this is the differential housing which I had to take apart so I could machine off this reference feature on here, because in this new design, this modified design, the pulley itself needs to go a lot further on and it's referenced on the outer edge instead. So we've got that. Made some design changes over the previous one. Mounts in a slightly different way. So it's got this recess now, so it actually mounts on the end of that instead. And then these are pocketed because I've got these 4 little M3 holes here, and they hold on the other side of the belt guide. I'll show you that in a minute, but let's now try this one. So this is the new one. Let's hope it fits. Okay, it's on at the top. I think we're going to call that a success. Brilliant.
So here we're machining out that belt guide I talked about just a moment ago. So first of all the 4 holes, and then these are countersunk to take the countersunk screws. And then I threaded the fixture underneath so I could screw one of those in just to hold the workpiece in place while it's being machined and stop it vibrating and flapping about. Here we're coming in and pocketing out the centre. Then after that it was a 2D contour pass just to clean up those 3 bores, and then I did a profile cut with tabs around the outside, cleaned it up. Okay, let's go back to the workbench.
Okay, so we were just talking about those M3 holes which are added in this design, and that's to take this belt end plate guide here, and that goes on like that. And it's held on with these M3 countersunk screws, and then I pocketed these out so we can still get the main attachment bolt on, and that ends up looking like that. So I think that should be a much better solution to holding the belt on itself. Okay, so let's start by putting this one together. Okay, so here's our screws. M3 countersunk. So hopefully if I made these countersinks deep enough, these should be flush or slightly under flush. Just snug each one down slightly so it starts to centre on those tapered edges. Okay. There we are, there's our new pulley. Brilliant, quite pleased with that. Right, now let's fit it onto the differential. So that should just drop on there into that recess. There we are. That lines up quite nicely. Let's get the 2 little M8 cap heads in. looks good. Right, next we'll build the main axle, and then we'll put this on, put the drive gears in, and then I think this time we'll put these idler gears in last, because it can be quite difficult to line all the gears up and get them to mesh, so I think if we put those in last it should be a little bit easier. Right, let's get the axle assembled next. Okay, so earlier you saw me straighten these out, so they now line up quite nicely with the holes. So to get the differential on, we'll put that through there. And then get the drive gear on. Alright, and then repeat for the other side. There's a keyway in there somewhere. Okay, line up the keyway. Should go on. Yes. Okay, and we'll drop it onto the frame. Let's try it with the bearing in. Okay, line up the keyway. Okay, let's line it up on the frame. Hopefully it fits. Let's not forget to put the belt on, so we'll get the belt through there, get these loosely connected, and then we'll put the idler gears through the center. Okay, so I'll get the belt on next before I forget. Oh, that's good, it just fits. Going well so far. Always the last one, isn't it? Come on. What's going on? The reason I was having problems was it looks like I haven't tapped it deep enough all the way through. Right, let's get the tap out and drive that all the way through, and then I'll bring you back. Try that one again. Now I've tapped the hole out. That looks better. Right, before we fully tighten it down, let's get these idler gears in here. Right. This is the fiddly one. There's just enough room for the teeth to slip past each other to get everything in alignment, but it's very tight. Should have really allowed a little bit more space. Nearly. There we go. Okay, and the locking grub screw. That's good. Grab the right one first time. This is all a dry assembly, so there's no Loctite on anything. Let's just make sure it's all going to work first. Okay, so I'm just trying to get a nice mesh on these teeth so they're all aligned. Feels pretty good there. Right, so we'll lock those in. It's going to be a little bit of trial and error. Okay, so as you can see, I've now just added the drive hubs on the end. I've put the brake discs on. I've got them about the right distance from their datums. Then the diff's in, and that mesh is just set correctly and then locked in place with the grub screws. Pulley's on, belt's in place, disc brake on the other side, and then the drive hub on the other side, and everything's locked in place. So what we'll do now, because this is the underside, we'll turn it over, put the motor on, and just check it all lines up. Okay, you might have seen this in one of the earlier videos. This is the motor that Banggood sent me. So it's a 24 volt DC motor at 300 watts. The unloaded speed, 2750 RPM, max current 17 amps. I roughly worked out maybe this will do 15, maybe 20 miles an hour. Remember, it's just from my daughter and I want to be able to keep up if she flies off into the distance. So we'll see how it goes. I have actually run this up. It sounds quite nice, runs quite smoothly. It's not really, I can't feel any end play. Feels quite nicely built, the castings and so on. Well, two real complaints really. The weld at the bottom there is already starting to rust, so I guess I could spray over the top of that. I've not had these long and they're starting to rust when I got them. Then the other complaint really is that this base plate here, this is not flat. I don't know if it's pulled slightly when they've welded it. It's moved quite a lot, so I wonder if the pressing itself wasn't particularly flat. So this surface here is very flat. This is a flat plate, and if I put it onto here, you can see, there we are, that it wants to wobble around slightly, and of course it needs to be square to the belt, otherwise it's just going to wear this out prematurely. So I'll have a look and see if I can straighten that up, but just for now let's just see if we can get it into alignment. We're just going to get it roughly into position. Right, let's get the belt on next. Now, because I remade this pulley, I had a look at my calculations for the speed and I decided to make this, I think it was a 46 teeth instead of 48. So I know this belt is now a little bit too big, but we'll just use it for alignment. I'll just need to order the next size down. But just in terms of alignment, let's see if it now will fit. Critical thing though is it now in line? That's loosely in place. Okay, not easy to get the right camera angle, but maybe there. You're looking pretty much straight down on it now. That looks pretty straight. Let's see if I can turn the motor by hand. There we go. Yeah, obviously this belt is too long. Need the next size down, but right, feels like we're getting somewhere now. Okay, so I'll order a new belt, get this plate straightened up, and then we'll catch you on the next one.